The Chesapeake Bay is the largest estuary in the United States and the third largest in the world. Over 64,000 square miles, from New York down to Virginia, drain into its tributaries. After a century of decline, a focused effort over the last 4 decades has brought this ecosystem back from the verge of collapse. But we still have a long way to go to a healthy bay. We've embraced technology as a way to prioritize conservation and restoration projects, putting the right practices in the right places. Data sets like the National Land Cover Database have been instrumental in our region's efforts. And while this data works well for modeling across the entire watershed, there is a fundamental disconnect between the data that was being used for planning and the data that we needed to implement specific actions that move us toward our restoration goals. So we worked with our partners in the Chesapeake Bay program over 18 months. And in December of 2016, we released a region-wide, ultra-high resolution land cover data set. This data is fundamentally changing the way that managers think about conservation and restoration. It's providing us with actionable information and refining the way that we can evaluate the benefits of individual projects. Our partners are already asking us when we're going to update this data, but the cost and time of our current methods are too high for us to do frequent updates. What we needed was a faster and cheaper way to make new data. ArcGIS Pro is reducing the amount of time that it takes us to go from raw imagery to land cover. We're creating a new false color image using the Nape image service, which is more than just a base map, and segmenting it. We're training a random trees algorithm on a subset of our imagery, and then we're streamlining our entire classification workflow into one processing model. We can run this locally and classify just our study area, or by leveraging Image Server in the Microsoft Cloud, we can create a land cover classification for an entire landscape. In fact, we can create a base classification for the entire Chesapeake Bay watershed in a little over 150 hours. That's pre-processing, segmenting, and classifying over 2 terabytes of the most recent Nape imagery. If we were to run this in our offices, it would take us over 2,500 hours. And now that we have 2 dates of land cover data, we can begin to dissect the changes that are happening across the landscape to better understand how this is impacting our local streams and rivers. To tell us a little bit more about that, here's Cass.
Thanks, Jeff. These processing advances enable us to focus more of our energy on prioritizing conservation and restoration actions. In the Chesapeake, we're facing a 2025 deadline to meet our restoration goals. Meanwhile, our watershed adds 100,000 new residents each year, increasing pressure on our landscape. Decision makers need scalable tools to help them balance this growth with our environment. To see how this translates across a single county, let's take a look at Albemarle, outside of Charlottesville, Virginia. In this county, managers could spend all of their time just assessing these 53,000 parcels and establishing priorities. This is an overwhelming, expensive task, and we know it's likely that only a small percentage require our immediate attention. We can now find these areas with an on-the-fly process in ArcGIS Pro that compares 2 years of land cover data and show where we have lost tree canopy, such as what's popping out here in orange. This layer is integrated into a county-wide analysis to show a manager where water quality monitoring or restoration could be most beneficial, here highlighted in yellow. This workflow is easily adapted to allow a manager to see where buildings and roads have been constructed. Once we know our priorities, we can create customized action maps for our local partners, like this one for a tributary along the Rivanna River. These developments seem minor when considered in isolation, but there are 206 counties in the Chesapeake Bay watershed. Most are experiencing growth, and cumulatively, the impact on water quality is significant. Our Bay cleanup deadline, 2025, is right around the corner. Together, Image Server and the processing capacity of the cloud are enabling us to spend less time making the data that we need to meet our goals and more time on conservation. Having this capacity at our fingertips is incredibly exciting, not just in the Chesapeake, but across the country and potentially across the world. Thank you.